The Disease Classifier mobile application has evolved from the older plant disease application that was originally developed in 2016 for Windows Phone platform, and it was based on a new simple but efficient method of disease classification. This classification method was based on grading the position of a feature value in the distribution of the training values. Let's see the common characteristics of both the old and the new application. The feature we use the features we use are derived from the sick plant part image segmentation in four regions: the normal plant part, the lesion spots, a halo around the spots, and the background that is ignored. The list of features includes the number and the area of the spots, the start and the end of the peak of the histogram lobes that are constructed by the application for each one of the regions of interest. Whether historical data such as moisture and temperature for the area of the cultivation can be retrieved from websites and used as features. This plant disease classification method has also been used in a similar skin disorder application. The new disease classifier application can be used for both plant disease and skin disease classification, as well as other similar applications where the screened object can have abnormal alternations in its color. For example, fish or animal diseases and skin disorders, or monitoring engine parts for malfunctions, for example. In this video, we will focus on the use of disease classifier for plant diseases. This application was developed using Microsoft Xamarin Platform, thus it can be deployed as Android or iOS smartphones, or can be used as a Windows application. A very important feature of this new application is that it can be used by agronomists for the support of new diseases. In other words, they are now responsible for training the application on new diseases, and they also can exploit the application, making it available to their customers for monitoring their cultivations. Let's see the whole process of training in using the disease classifier and the disease classification trainer applications. Assuming that the agronomist wants to train the system on tomato leaf diseases, and he has collected, for example, 20 photographs from the yellow leaf curl virus, then we can start the application and we can initially select the interface language. In this video we choose English, while in the comments of this video you can find the Greek version. Then we will start the disease diagnosis, we will select the disease diagnosis rules file, but since the system has not yet been trained in the diseases that we desire to support, we simply select the default file that will not be actually used. We leave all the other fields to the default values. In the next page, we select the image that we want to analyze. The two threshold triplets determine how background and the spots will be separated. Although calibrating these thresholds can lead to a more accurate segmentation of the regions we mentioned earlier, the normal plant part, the spots, the halo, the background, it is preferable to keep some predefined threshold values, at least for the specific type of coloring that we see, in order to avoid confusing the end user with the threshold calibration process. Let's assume that the sick part of this plant are the yellow regions that are actually brighter than the normal leaf, so in this case we should tick the invert checkbox. We analyze the image and see the results of the segmentation. Background is colored in white, normal part in gray, spots in black, and the halo created around the spots with fixed width is colored in a brighter gray tone. We can bring the initial image back in order to validate the quality of the segmentation results, and if necessary we can improve it by modifying the thresholds. We can also see the histograms of each region, although this does not concern the end user. In the next page, the feature value list that will be used in the classification appears. Since we are in the training phase, we click the training button and the values of the features are stored in the default text file in the memory of our phone. Returning to the previous page, we can select another training photograph, analyze it, move to the next page, and also click on the train button to add the features of the second photograph to the default file. The same process is repeated for all the photographs of the same disease and then for the training photographs of the other diseases. When the registration of all the feature values is completed, we open the Disease Classification-Trainer application. Here we choose again the interface language and then we select one of the files where the feature values of each disease were stored during training. For example, we can select range file, and all the files that you see here were derived from the previous process that we described in the disease classifier and contain the features of different diseases. For example, we can select the bacterial spot. We define the name of the disease. We also define the message we want to display, blah blah. This message can be some direct instructions to the producer or maybe a link that where the producer or in general the end user will find more information about the specific disease. And then we press Add Ranges. We also repeat this process for other diseases. Now I selected the healthy plants images. A different message and then add ranges. At the end, when all the diseases have been declared and their values have been, their feature values have been loaded, we define a name of the rule file, new test rules, and press the generate rules file. And this file has now been stored in the memory of the cell phone. We return back to the disease classification application, this time to classify new photographs. In the first page, we select again the interface language and the rule file that we just generated earlier from the Disease Classification-Trainer app. Now we have selected a rule file containing valid rules and a new feature of this disease classifier application is that we can define multiple ranges and compare if a feature value is within them. This is actually a check on the position of a feature value in the distribution that has been created during training. In the older plant disease versions, there were only 2 ranges. Now we can define up to 10 ranges. The default ones are the strict and the loose one. And in the new disease classification, as I said earlier, up to 10 ranges can be defined with customized weights. In the next page, we select the photograph that we desire to analyze. We do analyze it, and we proceed to the next page, where here we see again the feature values that have been extracted, but this time we do not click on the train button since we're not in the training phase, but we proceed with the next page. If we want weather data to be taken into consideration, these two pages can be used. And in the last page, we have the classification results. As you can see, the yellow leaf curl was successfully recognized since it received the higher grade 59. And after this tour to the plant disease classifier and the disease classifier classification trainer application, you saw how easily this platform can be used by agronomists who desire to offer their own set of supported diseases to their clients. So to watch any new developments about these applications, please follow my YouTube channel and thumbs up to this video. You can contact me for more technical information in the email I give in the comments. Thank you very much for watching this video.